Hello everybody, welcome, and we are now going to do the first part of 3.2. 3.2 is kind of a heavy section. There's a lot of stuff in here, so we'll just get the first part done today. So first we're going to go ahead and start talking about an AND statement. And so the definition for that, officially, the fancy word is called a conjunction, okay? And what that really means is we have two statements connected with the word and. Okay, and it doesn't necessarily have to be the word and. There are other words that you can use as well. For example, but, yet, and nevertheless. So those are the main words that you will see to form conjunctions, but most of the time we use the word and to connect two statements together. So for the first example, and so right now it's really just going to be, they're going to tell us what P represents, what statement that is, and what T represents. And then they're going to kind of mix some things around and try having us write what that looks like symbolically. Okay. So with that being said, okay, because we're not going to write out all these sentences, we're going to use symbols. Okay, the notation for and is just this upside down V or a caret. Okay. So when you see this symbol, just remember that it means and. Okay. And when you're translating, this is how you would do it. So for example, P, for example 1, a student places into developmental math. T, a student takes developmental math the first semester. Okay, so now those are the two statements. And now here we have a combined version with both of them into one conjunction. A student places into developmental mathematics. So that's just P. But is the same as and. They do not take. So since T is a student takes, and here we have does not take, we're simply going to negate T. And that's it. Okay? So just to make things clearer, here is P. Here's P again. And here's T. And here's T again right here. Right? And the fact that we have a does not, okay, that's but translates to and, which is this symbol. And since we're negating, we use the negate symbol. Okay, I'm probably overcomplicating this, but I just want to make sure it's very clear. Okay, for part B, a student does not place into developmental math. So that's basically P, but it's negated, right? So we're going to do negation of P. Yet and, same thing. So we use the symbol. And then it's they take, develop. So there's no negation there. It's just exactly the way T is worded, minus some adjustments for grammar. Okay? So that's it. Those are and statements. Now we go on to or statements. Okay, so for or statements, we have two statements, and this is the fancy word for it, disjunction. Two statements connected by the word or. And it's interesting to note, um, in the English language, we use or kind of in different contexts. So for example, oh, this is perfect. So this first statement here, when you go to a restaurant, sometimes you get a choice, either a soup or a salad, to come with um, your meal. So when the waiter or waitress asks you, do you want soup or salad, usually you pick one, right? And that's called an exclusive or, where you just pick one or the other. Now, when they approach you after you've eaten your meal, right, a lot of times they'll ask, do you want coffee or dessert? And that's actually an inclusive or, because you can say, yeah, you know what, I'll have some coffee and I'll have a slice of pie. You know, so you're welcome to have both, or maybe you just want some pie, or maybe you just want some coffee afterwards. And so it's interesting to note that in different contexts in the language, you know, or could mean a couple of different things. But we're going to focus on the mathematics behind it. Symbolically, the notation is kind of like the and symbol, but now it's flipped. So here we just have what looks like a V. Okay, that's it for the symbol. And for example 2, same kind of idea as example 1. So let's go ahead and just read these sentences. P represents a student places into developmental math, same as before. T, a student takes developmental math the first semester. So it's the same two P and T definitions. So now for part A, we have a student places into developmental math. That's just going to be P. Next, we have or, so we use the or symbol. And now it says does not take, so that's negated for the T statement. And that's it, okay? Mathematically, you would read this as P or not T, okay? On the previous page, for example, this one, you would read not P and T, okay? If we're just like using symbols and letters, we don't want to say the entire sentence. Let's look at part B. So for part B, we have a student does not place into developmental math. So right here, the does not tells us we're negating the original statement for P. Or, so we have the or symbol. They don't take, so again, they are negating T. So this would be how you'd write part B symbolically. Okay? All right. So now we have where there's 4 parts for today anyway. We're on the 3rd part, and that is going to be if-then statements. And this is kind of now the beginning of where we really got to slow things down a little bit and make sure we understand the consequences of these. If-then statements are used all the time in the English language. You know, for example, if we were in person, a lot of times I like to use this example. If we all get A's, if you all get A's on the first exam, then I will bring in pizza for everybody for lunch, right? Or maybe if it's in the morning, I'll bring in donuts, something like that. And we use that in the English language all the time. What we're going to eventually move towards is determining, you know, how we know if these statements are going to be true or false. But for now, we're just going to kind of explore. So here's the fancy word for it, a conditional, okay? And you can kind of understand why it's called that, right? Because there's a condition involved. For example, what I just said about bringing in pizza if everybody got A's, the condition that needed to be met was everybody getting A's, right? So that's why this is called a conditional statement. And so the definition is 2 statements connected with the words if, and then you got usually something else, and then you'll see a then in there as well. Okay, and similarly with and statements, you can use different words to mean the same thing. Again, we will probably deal with mostly if and then, but all of these scenarios here mean the same thing and have an if-then translation. So for example, all A are B can also be written as if A, then B. Okay, and a good example would be, let's say, all elephants are big. You can kind of reword it and say, if you have an elephant or if an animal is an elephant, then that animal has to be pretty big, right? So you can kind of think of it that way to determine what order and all that to go in. A is necessary for B. That actually is going to be written as if B, then A. Okay. What's a good example there? For example, being 16 is necessary for driving, right? So think of it that way. Being 16 is necessary for driving. Now let's try to rephrase that using if and then, right? So the only way it would make sense is if you're driving, then you have to be 16. Okay? A is sufficient for B. That translates to the same order, if A, then B. And same with this last one. Okay? But again, so this is the one that you kind of have to be careful with. When you see the word is necessary, just remember that the order for that one, that's the one that's kind of backwards of what you see. Okay? All right, so let's look at example 3. So P and T are the same exact statements as before. We're just going to read each one of these and kind of translate it. So here we have a student must take developmental math their first semester if they place into developmental math. Okay, so you kind of have to think about, and this is not worded with if and then, so you have to think about what the condition is, right? What is the condition? Oh, totally forgot to write down the symbols up here. I'm trying to write these symbolically, and I didn't even tell you the notation. The notation is going to look like this. Okay? It's just an arrow pointing one direction to the right. And so like these would all be, well, this one up here would be written like that. This one would be if B, then A. That's how you would read that. And this one is if A, then B. And so is this one. If A, then B. And that's how you'd write it symbolically. All right, so let's look at example 3 again. A student must take developmental math their first semester if they place into developmental math. So it looks like the condition here is they placed into it. So if you place into developmental math, right, notice here's the if. So that would be P. If they place into developmental math, and it's kind of like an implied then at the beginning here. Then a student must take developmental mathematics. So that'd be written this way. Okay. Again, this is not a typical or a common way to say it, but it means the same thing. All right. Here we have a student placing into developmental math is necessary for a student. Okay, so here's that is necessary. This is the one that's going to be flipped from what order we see in the sentence. So a student placing into developmental math, that is P, right? And then we have taking developmental math first semester, that's T. So we're going to go T, then P. So if T, then P. And that's my bad. I don't know why I used Q up here. This should be if P, then T. Okay. If a student does not place into developmental math. So this is a lot more straightforward. Okay, and this is what you really need to be like 100% with. If a student does not place, that sounds like P, but negated, right? So we're going to go negation P, then we have then, so there's our arrow. They will not take, so then that would be also the negation for the second sentence. So symbolically, we have, and this is how you would say it, if not P, then not T. Think about how that translates, right? If a student does not place into developmental math, then they will not take developmental math first semester. Okay. D, a student placing into developmental math is sufficient for them to take developmental math. So that's another way, right? Is sufficient is another way of saying if then, and so that's just going to be, and I don't see any negations here. Student places into developmental math, then they take developmental math first semester. So that's just going to be if P, then T. And last one here, a student takes developmental math their first semester only if they placed into it. Again, so the condition, it's always good. What's the condition in the sentence, right? The condition always goes first. So if you're having trouble with the formulas that we kind of covered over here, think about what the condition is, right? What condition needs to be met before something happens, right? Well, the only way a student's going to take developmental math in the first place is if they place into it, right? So that's the condition, placing into it. So that goes first, and that's sentence P. And then we have a student takes developmental math their first semester. That's sentence T. There's no negation. So this also translates to if P, then T. Okay, hopefully that makes sense. Just remember, if you know what the condition is that needs to be met, that's the first part when you write this symbolically. Okay, so that'll help you kind of keep track of what goes where. Alrighty, next we have what we call the biconditional. And this one's kind of, we'll talk about how we speak and talk about why it's actually kind of incorrect. And so anyway, here's the definition. Two statements connected with the words if and only if. Whoops. If and only if. So now, here's the funny part. A lot of times in the English language, when we say if, then, like the previous, a conditional, if you get an A, then you'll get some donuts. That's a conditional, right? And usually what that means, okay, is you get an A, you get donuts. You don't get an A, you don't get donuts, right? Well, that actually, mathematically, is an if and only if statement. Okay, and we'll talk about why that is, but here's a good example. So, and I'll kind of start previewing what we're doing next. So let's say your parents tell you if you don't clean your room, then you can't go to the movies, right? Well, the only way that they would have lied to you or that that statement would be false, if you think about it, is if you, okay, so you clean your room and then they don't let you go to the movies, right? That's the only way you'd be upset. So that's actually the only time um, that statement is false. Versus, let's say you don't clean your room anyway, but then your parents decide, oh, you know what, you can go. You're not going to be upset by that, right? And so that's the difference between an if-then and an if and only if. If and only if is a stronger statement, meaning one and the other have to be the same. So what we really mean is, let's use the in-class example. If everyone in this class gets A's on the first exam, then you will get pizza. What we literally mean mathematically is you guys will get pizza if and only if everybody gets A's. Okay? Anyway, that's kind of where things are headed. We'll get there. Right now, you just kind of need to know how to translate and how to write these sentences symbolically. So we're not quite there yet, but that's where we're headed. And here is the symbol for a biconditional. It's just a double arrow. Okay? And this is kind of indicative of, you can't have one without the other, right? And so a couple of things. If and only if, sometimes you'll see this abbreviated in math with IFF, okay? Mathematicians and math people by trade are a little lazy, so anytime they can shorten something, they will. Definitions are always if and only if statements, okay? And another way of saying if and only if is to combine the two things that we were talking about with conjunctions, or I'm sorry, for conditionals, is necessary and sufficient, right? So if we combine those two together, that means the same thing as if and only if, okay? And so these are now pretty easy to translate. So let's look at R. A student registers for a closed class. So R. Here we have a student can register for a closed class. That's where the R comes from. If and only if. So double arrow. They get an override slip signed. And that's exactly sentence S. Right? Pretty straightforward. A student can't take dual credit math. So how does that relate? M is a student can. Here we have cannot. So this is the negation of M. We have if and only if. So that's the double arrow. And then we got academic counselor does not say. And here we have academic counselor says. So this is also the negation of the second sentence. Okay? Hopefully this is making some sense. And then for the very last example, the academic counselor saying the student is eligible. So that's A, right here. Is necessary and sufficient is another way of saying if and only if. A student takes dual credit math, so that's M. Okay, so again, I know I probably elaborated on some things more than I needed to, but hopefully as we get to the harder stuff, having at least alluded to it, when we get there, it'll make a little more sense. All right, so that's it for today. We'll see you guys in our next meeting.